Zero exponents. Any base raised to an exponent of 0 equals 1. For example, 6 to the exponent 0 equals 1. 1/2 to the exponent 0 equals 1. And -4, the entire quantity, to the exponent 0 equals 1. Well, you might be wondering, does this make sense mathematically? Well, I'll try to make it make sense to you in the following way. Let's try the following explanation. From the laws of exponents, we know that 6 to the 3 divided by 6 to the 3, because we have the same base, would simply be 6 to the 3 minus 3. The quotient rule tells us to subtract exponents, which equals 6 to the 0. Okay? Now from BEDMAS, we know that 6 to the 3 divided by 6 to the 3, which is the same quantity we just determined equals 6 to the 0. 6 to the 3 divided by 6 to the 3 is 6 times 6 times 6 in the numerator over 6 times 6 times 6 in the denominator, which is 216 over 216, which is 1. Well, notice what we found is that 6 to the 3 over 6 to the 3 equals 6 to the 0. 6 to the 3 over 6 to the 3 also equals 1. So since both 6 to the 0 and 1 equal 6 to the 3 over 6 to the 3, these two quantities must be equal to each other. It's kind of a strange way of explaining something, I agree, but it's mathematically sound. From the first arrow, 6 to the 3 over 6 to the 3 equals 6 to the 0. From the second arrow, 6 to the 3 over 6 to the 3 equals 1. So that means 6 to the 0 must equal 1. Cool. Okay. Well, let's look at another thing that's sometimes counterintuitive for students, and that's negative exponents. Any base raised to a negative exponent is equal to the reciprocal of the base raised to a positive exponent. Well, let's have an example or two of this. For example, 2 to the negative 3 equals 1 over 2 to the positive 3, which equals 1 over 8. Another example, 1 over 5 raised to the exponent negative 2 is equal to 5 raised to the exponent of 2, which is 25. So what we're saying is that if you have a negative exponent, simply take the reciprocal of your base, make the exponent positive. We have a negative exponent, so we take the reciprocal of our base, and now we have a positive exponent. This one takes some practice to get used to. Okay, well you might be wondering, how does that make sense? Again, we're going to try one of those roundabout explanations. We'll try the following explanation. From the laws of exponents, we know that 2 to the 2 over 2 to the 5 equals 2 to the 2 minus 5, which is 2 to the negative 3. That's just from the quotient rule. Like bases, we subtract the exponents. All right. Well, from BEDMAS, we know that 2 to the 2 is 2 times 2. 2 to the 5 is 2 times 2 times 2 times 2 times 2, which would then come out to 4 over 32, or 1 over 8. And since we know that 8 is 2 times 2 times 2, we can say that 2 to the 2 over 2 to the 5 equals 1 over 2 to the 3. But up here we figured out that 2 to the 2 over 2 to the 5 was equal to 2 to the negative 3. So what we just established is that 2 to the negative 3 must equal 1 over 2 to the positive 3, since they're each equal to 2 to the 2 over 2 to the 5. It's a strange explanation, and it takes a little getting used to. We'll try it again. From the first arrow, we know that 2 to the 2 over 2 to the 5 equals 2 to the negative 3. And from the second arrow, we know that 2 to the 2 over 2 to the 5 equals 1 over 2 to the 3. So since these two things equal each other, therefore 2 to the negative 3 must be equal to 1 over 2 to the positive 3.